So we're going to kick this notes off by just sort of defining what an exponent is, getting some of the vocabulary down here so that we can all be on the same page. So this is a power. When you have a number raised to another number, and when you have an exponent, this entire thing we call it a power. The way you sort of read it is b to the power of x, right? So each of these two numbers has their own little name. This number, you probably already know what that's called. It's the exponent. And then the big number is called the base. So a power is made up of a base raised to an exponent. And as long as that exponent is a positive integer, the correct way to sort of explain what that means is just to say it's the base times itself that many times, right? That's sort of the simplest way to think about it. So if I have something like 2 to the 4th, that's a positive integer, right? It's just 2 times itself 4 times. 2 times 2 times 2. This is what you probably already know. I'm not saying anything new. All right, so what is 2 to the 4th? What does that equal? Yeah, it equals 16. Right. If I have 1 over 3 squared, I'm trying to simplify that. That just means 1 over 3 times 3, which is 1/9. So let's talk about what it means when you have 0 as an exponent. Like, what does 5 to the 0th power equal? I'm going to show you something up on the board that I think will help sort of make sense like what this should equal. All right, now after that little explanation up on the board, tell me, so what is the value of 5 to the 0th power? 1. So without, putting it in your calculator or anything like that, what's 3.7 to the 0th power? 1. What's negative 9 to the 0th power? 1. So no matter what the number is, if you raise it to the 0th power, you're going to get 1. Period. That's it. Now, you have to be a little careful with these negatives and follow your order of operations. If you don't have parentheses around your negative number, you have to apply the exponent first. If you think back to when you first learned about order of operations in PEMDAS, you learned that exponents come before multiplication. And so if there's no parentheses here, parentheses come first before everything, right? But if there's no parentheses, then you're going to do the exponent first. So if you see something like this where it's negative 9 to the 0th with no parentheses, you got to apply that exponent first. So 9 to the 0th is 1. Like this piece right here is 1. So negative 1 is just that, negative 1. Another way to think about this is that this is negative 1 times 9 to the 0. So what's y to the 0? Just say it's like some arbitrary number to the 0th power. 1. Now this is going to be pretty convenient later on when we start simplifying expressions. If you ever see something that's like, a to the 0th power or b to the 0th power, most of the time that's just going to simplify out. So to sort of sum this up, what happens when 0 is your exponent? Well, any number to the 0th power, 0th, is that really the word there? I guess so. 0th power.
Can it be to the power of 0? Or?
Yeah, to the power of 0. That reads a little better, right? I don't know why 0th just kind of sounds weird. To the power of 0 equals 1. Okay. All right, well, this is something you probably already know. You know, what's the value of 5 to the first power? We talked about that up on the board. It's just 5. Any number to the first power is just going to be itself, right? So if I have 3.7 to the first power, that's just 3.7. Negative 9 to the first power is negative 9. 1 is an exponent, sort of works the same way as if you had 1 as a coefficient, right? You never write 1x because 1 times x is just x. In the same way, if you ever have something to the first power, you can just sort of erase the power and be done with it. So negative 9 to the first power is negative 9. 100 to the first power is 100. Y to the first power is y. There's not a lot for me to say here. Just if you raise something to the first power, it's just itself. It's like having a coefficient of 1. So what happens when 1 is an exponent? Nothing, really. Any number to the power of 1 equals itself. Now that actually is true for 0 also. And so that's true for all numbers. Okay, so now we're getting into negative exponents. So I kind of want to go back and kind of show that pattern one more time just so that you see it again. Let's start with just 2 to the first. I'm going to do let's make a little chart over here. 2 to the first is just 2, right? What's 2 squared equal? 4, yeah, okay. What's 2 cubed? Right, that's 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. What's 2 to the fourth? 16. Okay, so I want you to focus on this pattern. 2, 4, 8, 16. Like, how do I go from 2 to 4, and from 4 to 8, and from 8 to 16? Like, what am I doing each turn? Yeah, I'm multiplying by 2, right? Times 2, times 2, times 2. Right? So if I want to continue that pattern backwards, from 16 to 8 to 4 to 2, I need to divide by 2 each time. Right? So from 16 to 8, I'm dividing by 2. From 8 to 4, I'm dividing by 2. From 4 to 2, I'm dividing by 2. So 2 to the 0th, if I follow that pattern on, what's 2 divided by 2? 2 divided by 2 is 1, right? Remember, anything to the 0th power is going to be 1 for this reason. So let's continue it one more step so that we can answer the question. What is 2 to the negative first power? Try to do it without a calculator here. It's 1/2, right? Now, how are you getting 1/2? Right? Well, just continue this pattern, right? Half of 1 is 1/2. 1 divided by 2 is 1/2. So if we continue that pattern, let's keep going. What would 2 to the negative second power be? What's 1/2 divided by 2? Right, you have half a pizza, you cut it into 2 pieces, you get a fourth, right? Everything comes back to pizza with me. Okay, what about 2 to the negative third? 1/8. Something else I want you to take a look at. Look at the positive exponents, or the positive powers and the negative powers. They have the same number. It's just that the negative powers are all underneath a 1. So like 2 squared is 4, 2 to the negative second is 1/4. 2 cubed is 8, 2 to the negative third power is 1/8. So notice that 8 is sort of in both, right? So if you're ever wondering, like if you know, like what's 5 squared? Like, do you know that off the top of your head? 25, right? So if 5 squared is 25, then what's 5 to the negative second power? 1 over 25. Yeah. All right, good. All right, so let's answer some of these questions here. 2 to the negative first power, we said was 1 over 2. Right, which is changed. Oh, well, we didn't use a calculator. We kind of skipped that, right? No, we don't need this. What is 2 to the negative second power? So first of all, what's 2 to the second power? 4. So 2 to the negative second power has to be 1/4. 2 to the negative. Oh, so 2 cubed is 8. So 2 to the negative third power is 1/8. Okay. So as far as like a description on how you can find these negative powers is find the positive power first, then flip the fraction by putting the number under 1. Now, if your number is already like in a fraction, I'm going to show you how to deal with that so that you don't end up with like fractions and fractions and fractions. We don't want to deal with all that. But let's practice a few. So let's say we have 5 to the negative second power. So first, what's 5 squared? Yeah, so I'm just going to make a note, like in parentheses here. 5 squared I know is 25, right? So 5 to the negative second power would be 1 over 25. Negative 2 to the negative fourth power. Well, let's make a little note here. What is negative 2 to the positive fourth power? I mean, like negative 2 times negative 2, negative 2, 4 negative 2s. 16, right? So negative 2 to the negative fourth power would be 1 over 16. So if I just have x to the negative 7th power, it would just be, there's no number to evaluate here. 1 over x to the what? Positive 7th. So when you rewrite this using a positive exponent, you do put it in the denominator. Now, because of the way this works with these fractions, when I say you flip the fraction, the reason why I sort of worded it like that is because sometimes your negative power will be in the denominator. In that case, when you change it to a positive power, it's going to end up in the numerator. So, like for instance, 1 over 6 to the negative second power. Well, before we evaluate, what's 6 squared? Let's start with that. 36, right? So like this number in the bottom would be 1 over 36, right? This would be 1 over 36. But we don't want to have to deal with fractions and fractions. That gets really messy, and we really want to avoid that. So the reason why in the description I said flip the fraction is because when this negative power is in the denominator, when we change it to be a positive power, we move it to the numerator. 1 over 36 is equivalent to just 36. Whenever you have 1 over a number, the reciprocal of a reciprocal, it's like having two negatives. They just sort of cancel each other out. So another way to think about this is if you have a negative exponent and you're trying to rewrite it using a positive exponent, all you do is just take that power and move it to the other side of the fraction. So in other words, this becomes 6 squared over, and then the bottom will just be 1, so it'll just be 6 squared, which is 36. You can kind of approach it either way. I would advise against writing fractions and fractions, and instead just change all the negative powers to positive powers and move their position in the fraction. So, like on this one, before we evaluate anything, let's move the powers to where they need to go with having a positive exponent. So here's the negative power, right? So to change that to 3 to the positive 4th power, I'm going to just bring that up here, right? So I'm going to have 2 squared times 3 to the 4th, positive 4th. Now, whenever you are moving these things around, if you sort of move everything out of a side, like you get rid of everything in the denominator or everything in the numerator, then what's left over is just a 1. So you have like over 1. Now, you don't have to write the over 1, but I'm going to start doing that just so that you see like that it doesn't just disappear. It's just that when you divide by 1, you're not really doing anything. So what's 2 squared? 4. So this would be 4 times 3 to the 4th. Is it? Oh, good. Wow. It's not impressive. So 4 times 81 is, what's 4 times 8? Let's start there. 32. And what's 4 times 1? 4. So 324. For number 12, we've got the negative powers in the numerator. So to make this a lot easier, we're going to change that to a positive power, bring it down to the denominator. So that gives me 1, because I got rid of everything in the numerator, over 4 squared times 2 to the 4th, which I can evaluate separately. Yeah. What is 4 squared? 16. 2 to the 4th, 2 times 2 times 2 times 2. Actually, I think we wrote it up here. Yeah, so 16. So 16 times 16. So 16 times 16. Any idea? 256. So let's look at a couple of problems like that, where, well, I guess we have a few more that are just numbers, but then we're going to start getting into ones where they have a bunch of variables in there. So just to recap here, here are the rules for the 0, 1, and negative exponents. So if I have just any number, or here, I'll use x. I like x better. X to the 0th power will always equal what? 1. Good. X to the 1st power, what does that equal? Yeah, just x. X to the negative, we'll say a power, so just some other power, or maybe I should use the word, no, that's fine, equals 1 over x to the positive power. Now, a lot of times directions will say, oh, simplify this expression. And one of the things we've never talked about, it hasn't come up yet, but it will now, is that one of the implications when I say simplify the expression is that your final answer doesn't have any negative exponents in it. So, like if you look at number 16, that's not considered simplified yet because it's got a negative exponent. So we have to rewrite it using a positive exponent. And we'll get to that one. So let's knock out some of these. Let's look at number 13. Negative 5 to the 0th power. Now there's no parentheses on there, so we're going to apply the exponent first. and then apply the negative. So what is the numerator going to become? Like, what is negative 5 to the 0th power here? Well, let's start with this. What's 5 to the 0th power? 1. So negative 5 to the 0th power, negative 1. Now, this negative power down here, I need to move that to make the power positive. So it would be negative 1 times 2 squared. So what's 2 squared? 4. We get negative 1 times 4 is negative 4. For number 14, we've got a negative power here, so we need to move it to the other side of the fraction to change the power to be positive. What's left over in the numerator? What am I going to write in the numerator's spot? Yeah, just 1, right? Like if I get rid of everything, it's just 1's left over. So 1 over negative 5 to the 0 times 6 to the 1st power. Well, what's negative 5 to the 0th power? 1. And then 1 times 6 to the 1st is just 6. So my answer is 1 over 6. Now, number 15 has 2 different negative powers. So how am I going to approach this? Like at this point, I'm kind of hoping that you know what to do with this one. How do I make those powers positive? You flip them, right? You move them to the other side of the fraction. So this power is going to go down to the denominator, and we'll change the power to be positive. This power is going to go to the numerator and change the power to be positive. So then that gives me 4 cubed over 3, oops, not negative anymore, squared. So that's the first one where we've seen negative powers on both sides. So it's okay, you just move it to the other side of the fraction and make the power positive. So what's 4 cubed? Okay, oh good, 64, I'm impressed. Yeah, I wasn't expecting that. And then 3 squared is 9. I don't think this can reduce, so we're just going to leave it like that. All right, now's where it starts to get a little tricky. Let's take a look at 16. Okay, so we're just trying to simplify this, okay? So what that means is we have to deal with any negative and 0 exponents. So any 0 exponent, those are easy to deal with. Anything to the 0th power is just 1. So this d to the 0 right here, that's just a 1. So just like get rid of that right away. We don't even need it. 15 times 1 is 15, right? But then we've got this negative power right here. This needs to get moved to the other side of the fraction. So even though you don't like see a fraction here, you can still move it to like the denominator that you don't actually see. So this is going to be 15 over c to the 8th. There's nothing we can do at this point to simplify that further, so that's just your answer. Any questions about that one? All right, number 17. What happens to the n to the 0th? It's just 1. right? So this is just a 1. Now we've got two different negative powers. So we just sort of handle them independently. This one's going to go to the bottom. This one's going to go to the bottom. There's nothing left over in the numerator, so that just remains a 1 over 2 squared times m cubed. Now, if you do have a numerical power, like 2 squared, that's not a variable, I do want you to simplify that. So like, what is 2 squared? 4. So 1 over 4 m cubed. So if it's a variable, you can't really simplify. You just leave it with the exponent. But if it's a number, then I do want you to actually multiply that out. And you'll have a calculator. So even if it's something like 5 to the 6th power, I don't expect you to do that in your head. You just throw it in the calculator, you get that number. Number 18. 18 is pretty much exactly like number 17. Like, it's even set up in the same way. Y to the 0th, that's a 1. And then I'm going to take both of these negative powers and move them to the denominator. So I get 1 over 3 squared times x to the 5th. So what's 3 squared? So 1 over 9x to the 5th. So I've only got a couple more questions for you, and really it's just practicing more of this. Once we're done, I'm going to give you your homework, and you're going to have like a solid 25 minutes to work on your homework. You could probably finish most of it, I think. Let's take a look at these last few ones. There's a lot going on in these last couple of problems. 19. All right, so what's the first thing you notice about number 19? What's sort of like our first easy go-to, be done with it kind of a thing? Yeah, y0, right? So this is just a 1. We're just going to like sort of cover it up. We don't really care about that anymore. Multiplying by 1 doesn't do anything. Now we've got 3 different negative powers. Here's the tricky thing, though. When your power has a coefficient, like x to the negative 5th has a coefficient of 13 here. The 13 does not have a negative power, or any power. I mean, there's sort of an implied first power, but you don't write that ever. So 13 is not going to get moved anywhere. When you start moving things around, you're only going to move around the number or the variable that is like immediately attached to the exponent. Nothing in front of it. So the x to the negative 5th, that is what's going to get moved down to the denominator, right? And then both of these two things, notice how the 5 has a negative exponent, get moved up to the numerator. So we're sort of switching a lot of things. The only thing that's not moving here is the 13. So I have 13 times 5 cubed times z to the 10th over x to the 5th. Now, I don't know what 13 times 5 cubed is. That's definitely a calculator part of this. Let's see, 5 cubed is 125. Anybody have a calculator on hand? 125 times 13. 1,625. All right, 1,625 z to the 10th over x to the 5th. So notice that no matter what's going on here, we're rewriting our negative powers with positive exponents. All right, number 20. So there's a lot going on here. These are the kind of problems that can be like on your STAR exam, where you have just like a bunch of random stuff and you just got to know where all the variables end up. So first thing that jumps out at me is this z to the 0th. That's a 1, right? Is the 2 squared going anywhere? No, that's just staying where it is. It's a positive exponent. 2 squared is 4. Is the y to the 6th going, and y to negative 6th? Do we move that? Yeah, we move that. So I'm going to move that down to the bottom. 8 to the first power, or negative first power. That's negative, yeah, we got to move that. So 8 to the first power would be just 8. And then we've got x to the negative 7th power, so we got to move that too. All these arrows are making this look a lot more confusing than I think it is. So what's 4 times 8? 32. Okay, good. 32 x to the 7th over y to the 6th is your answer. All right, last one here. Number 21. We got all kinds of negative numbers. It's almost too many at this point for me to like start circling and putting arrows and stuff, because I think that really obfuscates what we're doing. So let's just take it one term at a time. So 4 to the negatives, like for each term, I just want you to ask yourself, does that stay where it is or does it get moved? So 4 to the negative 2nd power, what happens with that? It moves, right? So that you have a positive power. So you have 4 to the positive 2nd. Okay, we're done with that term. Now let's go to the next term. X to the negative 2nd. It's a negative power, so it moves. So x squared goes on the bottom. 6 to the negative 1st power. Well, 6 to the, so we're going to move that up to the top. Move that up to the numerator. 6 to the 1st power. Y to the 0th. Well, that's just 1, so we can just sort of eliminate that. And then z to the negative 3rd means we're going to put z cubed on top. Basically, it looks like everything on here changes position once you change it to a positive exponent. So we're pretty much done, except we need to evaluate all the numerical powers. 6 to the 1st is 6. So we have 6 z cubed. Oh, that's the ugliest z I think I've ever written. That is awful. 4 squared is 16, x squared. Any questions?